Okay, let's start 17.4. It does say practice. I just have a few notes, and then we'll do some of the practice with you. Okay, a couple of rules. Note, when two triangles are similar, we know then that their angles are congruent and that the sides are proportional. So that's what these first two rules are just saying, and I just already wrote it in for you. CASTC, that means that corresponding angles of similar triangles are congruent. So the corresponding angles, when the two triangles are similar, so corresponding angles of similar triangles. So you have similar triangles, their corresponding angles are congruent. And we've learned that already. But that's the reason you could show two angles are congruent after two triangles have been shown similar. And then the sides. The corresponding sides, when you have similar triangles, so the corresponding sides of similar triangles are proportional. That means you can set up those fractions and set them equal to each other from one triangle to the other. Okay, so once two triangles are shown to be similar, then you can set up the ratio of the sides. Okay, now, first proof. I've already kind of filled it in. If I mark the parallel lines that have been given to me, e.g. parallel DH, I mark the parallel lines. That's given. Okay. Now, angle D, it's written down in my statement, angle D is congruent to angle FEG, so I need to figure out why. Well, since these two lines are parallel, those two would be corresponding angles. Corresponding angles would be congruent. Now, the next statement says reflexive property. Reflexive property, we've used it with the same side being in two triangles, but what about angles? Sure, if there's an angle that's in two triangles, or the same angles in these two triangles, that can be used as, we can use reflexive property for an angle as well. So we'll say angle F is congruent to angle F. Now we have an angle, this angle in both triangles, and these angles in both triangles. So now, by angle, our triangles are similar. Okay? Now let's go to the next one. So we're going to work some of these, and I'll let you work a few on your own, just kind of doing this with you to the end of the packet here. Okay. So on number 2. So we're given these ratios. Okay? So we know that WY, okay, this one matches up with BC. So I'm just going to make like a dot just to note which ones match up. Okay? And then YX, I'll do 2 dots with AC. And then WX with AB. This is not an official notation, but I'm just looking to make sure I know which ones match up with which ones. Okay, so if I need to write the statement, or here's the statement here, make sure I know what's what here. So what's given, we'll fill that in, WY over BC. So basically what's given are that the sides are proportional. Right? The sides are proportional. So their triangles are similar. Yeah, WXY, BAC. They should be similar because of side similarity. Because all three sides are proportional to the three sides of the other one. So now because these triangles now are similar, how can we say angle W is congruent to angle B? Well, that's from our statement up here at the beginning. Once the triangles are similar, the corresponding angles of similar triangles are congruent. Okay? All right. Let's go to page 10. How many of these do you want to do? I probably could guess. So on page 10 and 11, we're looking at 1, 2, 3, 4, 5. So I'm going to do maybe number 7. I'll do 6. And then I'll do Well, you know what, I'm gonna do number 6, and then you can do the rest. So on page 11, number 6. Let's see here. Okay, so let's write down what's given. LQ is parallel to NP. So now I'm going to mark it on the figure. LQ is parallel to NP. So parallel lines, that's going to give me some congruent angles. Okay, so that's what I need, probably. Statement number 2 is then, I don't have any more givens. Oh, that's given. So let's go find some congruent angles from the parallel lines. So here's parallel lines, here's a transversal. So I could say angle N, well, L, I mean, NP. So let's go angle L is congruent to angle P, because those are alternate interior angles. From parallel lines, alternate interior angles are congruent. Now there's several ways you can go about this proof. Okay, you can get another pair. You only need 2 angles, right? So we have vertical angles here. You could go there and say, well, I'll write it down. This is one direction you could go. You could say angle LMQ is congruent to angle, if it's LMQ, then it would have to be PMN. Those 2 angles would be congruent because they're vertical. Vertical angles are congruent. Okay, now we have 2 angles, so the triangles are similar, because that's what we're trying to prove. Okay, if you didn't do that, if you used the other pair of alternate interior angles, then you would have said N and Q would be congruent, just like you did number 2 here with L and P. Alternate interior angles. So you could write that in as well, but you only need 2, so I chose those 2. So therefore, triangle LMQ is similar to triangle PMN because of angle-angle similarity. All right, that takes you to the end of the packet. Bye.